Kinematics Part 2. In this section, we are going to analyze motion graphically, which is also the main part for this entire chapter. Okay, so let's move on to the learning objectives. Okay, we will be focusing on the plotting and interpretation of a displacement time graph as well as a velocity time graph. Okay, so before we start, let's do a quick recap about what we have learned in part 1 of kinematics. So you may pause the video at this moment to think about the answers to these two questions. Okay, I'm going to go through the answers. The first question, velocity is defined as, so we recap on the formula for velocity. So the formula for velocity is displacement divided by time. So the best answer that suits it will be displacement per unit time, okay, which is D. Okay, the next question is a little bit more difficult. It says that Tom travels 50 kilometers in an hour and another 10 kilometers in an unspecific amount of time. His average speed for the entire journey is 10 meters per second. Calculate the time he takes to travel the final 10 kilometers. In this question, you can see that I have a mixture of different types of units. I have kilometers, I have hours, I have meters per second. So before we start into any formulas, it is important to change every quantity into the SI units. That will make your calculations easier later on and it will be accurate. If you don't change it, then there will be a conflict of units. Okay, so I'm going to change everything into the SI units, which is kilometers, hours, and kilometers back to convert it into meters and seconds. So the first one, 50 kilometers, I were to change it to meters. We know the prefix kilo means 10 to the power 3, so it'll be 50 times 10 to the power 3, which is 50,000 meters. 1 hour is 3,600 seconds, and then 10 kilometers will be 10,000 meters. Okay, then the only information that they give you is the average speed. So I'm going to use the formula for average speed is total distance over total time. So when I have total distance over total time, I am going to substitute my numbers in. So the average speed is given 10. The total distance is actually 50,000 plus 10,000 meters. It's 60 kilometers or 60,000 meters over the entire time. Okay, the entire time, it takes 1 hour plus the unknown time that he takes to travel the last 10 kilometers. So I'll just take 3,600 seconds plus X. X is the unknown time. So if I were to solve the equation, I will get X is 2,400 seconds, which is also equivalent to 40 minutes. So the answer for this question is D. Okay, so let's move on into this second part of kinematics. Okay, the first one is we are going to interpret what is a displacement time graph. Okay, so what does displacement time graph means? It simply means I am plotting displacement against time. Okay, displacement will be on my y-axis, while time will be on my x-axis. Okay, so this is what I mean by displacement time graph. And then you need to understand that every time when we are analyzing graph, other than just analyzing what is the y-axis and what is the x-axis, very, very often we look at the gradient of the graph. Okay, so the gradient of a displacement time graph is actually the change in displacement divided by time, y divided by x. So it's actually displacement divided by time. So the gradient of a displacement time graph gives the velocity of the object. It tells you about the velocity of the object. And gradient, you can also think of it as the slope of the graph. How steep or how gentle is that slope? Okay, so we are going to into 4 possible scenarios. The first scenario is when the car is at rest. So again, I say we are looking at the gradient of a displacement time graph, which is the velocity. So you think when the car is at rest, you must understand that the velocity will be 0. Okay, there will be no velocity, not moving. So if my velocity is 0, it simply means that the gradient will also be 0. So how can the gradient be 0? Means there is no slope. It is a flat line. So in this case, you can see that as the time progresses from 0 seconds 1 second, 2 seconds, all the way to 5 seconds, the displacement stays constant at 20 meters. So my object is always stationary at this point, 20 meters from the starting point. So if I were to plot on a graph, it will be a flat line. The gradient is 0, velocity is 0, not moving at all. Okay, scenario 2 is when the car is moving at a constant velocity. Constant, it means like uniform, it means same velocity of 10. So now the car is moving. Okay, so every 1 second, you can see from here, every 1 second, my car moved by 10 meters. Okay, so the car is actually moving. When I'm moving, I have a velocity, and this velocity is constant, means it's the same. So I will have a straight line graph, because a straight line graph will give me a constant gradient. The gradient at 1 second is the same as gradient at 2 seconds, is the same as the gradient at 5 seconds. The steepness of the slope is the same throughout everywhere on a straight line. So once you see the word constant, most probably you get a straight line graph. Okay, next one is when the car is traveling with increasing velocity, or we call it that is accelerating, means moving faster and faster and faster. Okay, so if I'm increasing velocity, it is the same meaning as increasing gradient, because velocity is the gradient. Okay, so when I plot my displacement time graph, I will get an increasing gradient, means my graph will become steeper and steeper. Okay, so what does it mean? The slope will get steeper and steeper. If you can see, let me just use blue color. Okay, initially my slope is like this. It's not very steep. And along here, I will get steeper. And along here, my slope will be even steeper. Okay, so the gradient or the slope is actually increasing. Okay, so I have increasing gradient, which also means increasing velocity. Then vice versa, now I have a car moving with decreasing velocity, means that I am slowing down. Okay, decelerating in other words. So if I'm decreasing velocity, I should have a decreasing gradient, means my slope will get more and more gentle. Okay, so you can see again the blue line at the start is very steep, and then it gets more and more gentle over here, and here is almost going to be flat. Okay, so this is decreasing gradient, which means decreasing velocity, which also means that I am slowing down, I am decelerating. Okay, so over here you can take a look at here. I have a graph that shows the motion of a car moving from A all the way to G. And then you need to describe. Okay, so first step in describing, you take a look at what does the axis represents. Okay, so the y-axis represents the displacement, the x-axis represents the time. So it's a displacement time graph. And immediately in your head, again, before I describe graph, you think of the gradient. Okay, the gradient of a displacement time graph gives me the velocity. Okay, so I'm going to explain in terms of velocity. Okay, so the first section, A. Okay, the gradient is 0. It means I have 0 velocity. It simply means that the object is not moving. The object is stationary at a distance of 40 meters. Okay, from my starting point. My starting point is X over here, 0 meters. So at the start, I will be at the green flag over here, 40 meters. From the starting point, I am not moving at all. Okay, next, I'm going to move on to B. Okay, this point B is on a straight line. Okay, there is a gradient now. And this gradient is a constant gradient. It's the same gradient because it's a straight line. So if I have a constant gradient, it means that I am having a constant velocity. The car is moving with a constant velocity. So I'm moving at this stage and have a constant velocity. The next point at C, okay, the gradient at this part is actually 0 again. Okay, the gradient at this point is actually a flat line. So if I have zero gradient, it simply means I have zero velocity. Okay, the gradient is represented by this dotted line. Okay, zero gradient, zero velocity means I am not moving. But at this point, I'm no longer at 40 meters from the starting point. I am at a distance of 100 meters from the starting point, and it's shown with the purple flag over here. Okay, so at point C, I am at this particular instant where I'm at 100 meters from my starting point. Okay, next, okay, we go from C to F. Okay, take note that now from C to F, my gradient has becomes negative. Okay, so if I have a negative gradient, it means that I have a negative velocity. And you have learned in the previous part, velocity is a vector, there is positive and negative. So if there is negative velocity, it simply means I am moving in the opposite direction. So the car is no longer moving forward towards the right. Now the car is moving in the opposite direction, which is to the left. So from C to F, the car is actually moving backwards to my starting point in the opposite direction. Okay, then let's zoom into the region of DEF. Okay, in the region of DEF, you can see that other than the gradient is negative, means I'm moving backwards, you can see that the gradient of the line is not constant. It's not a straight line. It's actually a curve. And the gradient is getting more and more gentle. Okay, D is very steep, then followed by E, and then F is almost going to be flat, the gradient, the slope. Okay, so it's the gradient actually decreases. So if I have a decreasing gradient, it means that I have a decreasing velocity. Okay, it simply means I am slowing down. Okay, so this car, as it moves backwards, it is slowing down, which is represented by the arrow. It's moving slower and slower and slower and slower from D to F. Okay, it is decelerating, or the velocity decreases, moving with decreasing velocity. And the last part at G, okay, is again a horizontal line. The gradient is zero, means zero velocity, is not moving at all. And now it is 20 meters from the starting point. Okay, so I'm at the red flag here, which is 20 meters from my starting point. At the start, I actually move off from 40 meters, from the green flag to the blue flag, and then from the blue flag, I am moving backwards all the way until I'm 20 meters from the starting point. So this is how you interpret a displacement time graph. Okay, so you may scan the following QR code to practice on yourself more. Okay, next we move on into a velocity time graph. Okay, so the same like displacement time graph, velocity time graph simply means I am plotting velocity, okay, which is in meters per seconds, against time, which is in seconds. Okay, and again, other than looking at the axis, velocity and time, whenever we are describing motion, we tend to describe the gradient. So the gradient of a velocity time graph is the change in gradient, y, divided by x, which is the time. So the change in velocity for every second is actually the acceleration. So the gradient of a velocity time graph gives you the acceleration of the object. So let's go into the different scenarios again. The first one is again the car at rest. When my car is at rest, my velocity is zero and my acceleration is zero because I'm not moving faster and faster and faster. So if my acceleration is zero, it simply means that the gradient will be zero. So it should be a flat line, and because the car is not moving, the velocity is zero. So the flat line must be on the line zero. The second scenario is when the car is moving at a constant velocity. Okay, when my car is moving at constant velocity, I am not moving faster and faster and faster. That means throughout the seconds, every 1 second in this case, my car speed is always, or velocity is always at 10. I'm not moving faster and faster. I'm always maintaining at the same velocity. So if my velocity is constant, my acceleration is zero. I'm not moving faster and faster. So acceleration is zero. So acceleration is zero means gradient is zero. Again, it must be a flat line. Okay, but this flat line will not be at 0. This flat line will be at the constant velocity of 10. That means at every 1 second, the velocity is always at 10. So this is what I mean by constant velocity, 0 acceleration. Okay, the next instance is when the car is moving now with a constant acceleration. Again, once you see the word uniform or constant, is a straight line. So constant acceleration means constant gradient. The gradient is the same. So how can the gradient be the same? It must be a straight line up. Okay, and because it's acceleration, okay, so the velocity must increase. I'm having a constant acceleration, my velocity increases. Okay, the next one is when I'm having a constant deceleration. Again, constant deceleration, I need to have a straight line again because it's constant. The gradient must be constant. But if I am decelerating, my velocity decreases. Okay, so at time 0, I'm at 50. Okay, my velocity is 50, and then at time 3, my velocity is at 20, and at time 5, I totally stop. I am slowing down, deceleration constantly. Okay, so it should be a negative graph. Or, okay, once you get, this is positive gradient, just jot down. Okay, so this is, yeah, I can't draw. Okay, so this is positive gradient, means positive acceleration. Okay, this is negative gradient, which simply means negative acceleration, which also means I am decelerating. Okay, okay, next one. Okay, now my car is not moving with a constant acceleration. I'm moving with increasing acceleration. So if I'm increasing acceleration, means I'm increasing gradient. Okay, simply means my slope will get steeper and steeper. Okay, the gradient increases. Initially, the slope is like this, then it gets more and more steep, and finally very steep. And the same goes for decreasing acceleration, means decreasing gradient, means my slope gets more and more gentle. Okay, it's no longer that steep. Okay, next, you may pause the video over here to think about how would the velocity time graph looks like for a car moving with increasing deceleration and decreasing deceleration. Okay, I'm going to go through the answer now. Okay, the word deceleration means that it's negative acceleration. Okay, so it means negative acceleration, which also means I must have a negative gradient. My line should be sloping downwards, negative gradient. Okay, and then the word increasing or decreasing will actually tells you about the steepness of the slope. Okay, so if I have increasing deceleration, the first one, okay, means my slope should be getting steeper and steeper, but negative gradient means I am sloping down. So it should look like this. Okay, number one is sloping down, so there's negative gradient, which means negative acceleration, also means deceleration, and my steepness is increasing. I'm getting more and more steep, from gentle, almost horizontal, to getting very steep. Okay, and then for second question, decreasing deceleration. Again, it must be sloping down, but in this case, I am like that. Decreasing means I'm getting more and more gentle. Okay, so this will be my velocity time graph. Velocity. Okay, every time you do a sketch, remember to label your axis. What is the y-axis representing and what is the x-axis representing? You usually need to write the quantity / the units. Okay. Okay, next we do a comparison between displacement time graph and velocity time graph. Okay, so you may want to write down, jot down a note. Okay, immediately whenever I want to interpret, I think of what does the gradient represent. So for displacement time graph, the gradient Okay, I put gradient over here. The gradient actually represents the velocity. And this one, the gradient actually represents the acceleration. Okay, so let's go into the first part. From A to B, they want that the car accelerates uniformly. Okay, the word uniformly is the same as constantly. Okay, so the question gives you acceleration. It will be easier to see the velocity time graph because the gradient will give you the acceleration. Since I am accelerating uniformly, means I will have a uniform gradient or constant gradient. Okay, so it should be a straight line up. I am accelerating, so my velocity increases faster and faster and faster. I'm moving faster and faster and faster, and it's constantly. Okay, so I draw my velocity time graph first. How to change it to displacement time graph? Displacement time graph doesn't have a link to acceleration, but it has a link to the gradient, which is the velocity. Okay, so you need to think of acceleration in terms of velocity. Acceleration, if something is having an acceleration, means that the velocity is increasing. I'm moving faster and faster and faster. Okay, so if the velocity is increasing, it simply means the gradient of this displacement time graph must be increasing. Increasing velocity means increasing acceleration, means increasing gradient. So the gradient gets steeper and steeper and steeper. So it will be a curve. Okay, next part, from B to C. It says that it's moving with a constant velocity. So velocity is given. I don't look at velocity time graph first. I look at displacement time graph first. Constant velocity simply means constant gradient. And again, constant gradient means straight line. Okay, so I should draw a straight line. Then next, I need to link velocity, constant velocity to acceleration. If I'm having constant velocity, means I am not moving faster and faster and faster. My velocity is always the same. So it means I have zero acceleration. Zero acceleration means zero gradient on velocity time graph. So zero gradient means a flat line on the velocity time graph. Okay, and then the last part, it says that the car decelerates uniformly. So again, decelerates means negative acceleration. Means I am going to look at the velocity time graph first because it gives me the acceleration. Negative acceleration means negative gradient. So my line should be sloping down. And it's constant. Uniformly means constant. It should be a straight line going down and all the way to zero because it comes to a stop. Velocity is zero at a stop. Okay, then next I need to link it back to again displacement time graph, which is velocity. Decelerating means that the velocity decreases. I'm moving slower and slower and slower. The velocity decreases. So decreasing velocity means decreasing gradient. So my gradient gets more and more gentle. It's decreasing. So you get a slope like this. Okay, so let's do a very, very quick summary or recap about what we have covered so far. Whenever we want to describe motions, we have two types of graph over here, displacement time graph and velocity time graph. For displacement time graph, the gradient represents the velocity, while for velocity time graph, the gradient represents the acceleration. And the gradient, there are many different types, and over here, I have some common gradients. Okay, when the graph is a straight line, a flat line, okay, a flat line, we say that the slope or the gradient is zero. So if it happens on the displacement time graph, then we say that it has zero velocity. If it happens on the velocity time graph, we say that it has zero acceleration. Okay, or we can use the word yes, a constant displacement or constant velocity. Okay, next one. Okay, as long as straight line, you can use the word constant as well. Okay, so the next type of graph is sloping up or sloping down, but it's still a straight line. So once you see the straight line, you can use the word constant. If it's a displacement time graph, then it will be a constant velocity. If it's a velocity time graph, it will be a constant acceleration or constant deceleration, depending on whether the graph is sloping up or sloping down. Okay, and then how do I describe other things that are not constant, or whenever I see a curve? Okay, the last 4 graph over here, you see a curve shape, it's not a straight line. Okay, I don't use the word constant or uniform. I use the word increasing or decreasing, depending on the shape of the graph or the slope. Okay, so in this case, it's getting steeper and steeper. In this case, and this case is also as the time progresses, I am getting steeper and steeper and steeper. So I am having an increasing gradient. So I'm having an increasing velocity or increasing acceleration, depending on what type of graph. Okay, and over here, okay, it's getting more and more gentle. Okay, as the time progresses, it gets more and more gentle, going to a flat line. Okay, so it's decreasing. So if it's a displacement time graph, it will be decreasing velocity or decreasing acceleration for velocity time graph. Okay, let's take a look at more word examples. Okay, this is a displacement time graph. Describe the motion of the car at each stage A, B, C, D to E, and E to F. Okay, you may pause the video at this point to think about the answers. I'm going to go through the answers now. For displacement time graph, the first thing you need to think about is the gradient again. The gradient of a displacement time graph gives you the velocity. So I'm going to explain the motion in terms of velocity. So the first part, A, flat line. Gradient is 0. So it means 0 velocity, which also means that the car is not moving. Okay, next, B. I am on a flat line. Okay, so at this point, constant velocity. I'm on a straight line, straight line. Okay, so straight line, I use the word constant. Yes, constant velocity. At C is again a flat line. The gradient at this point is a flat line, so it's not moving. From D to E, it's not a straight line, it's a curve. The gradient is getting more and more gentle, so it's decreasing gradient. So I have decreasing velocity, but it's in the opposite direction. Okay, because it's negative now. Gradient is negative. And then E to F is again a straight line. So velocity is 0. Okay, so you need to take a note from C onwards, the gradient is negative, means I'm moving the opposite direction. My velocity is negative, moving the opposite direction. Okay, then next, you can take a look at this example. Okay, now I don't have sections, but every time they give you a graph and they ask you to describe the motion of the car, you need to be able to segment the graph into different sections based on the shapes. Okay, so I hope you are able to see the first part of the graph is when the line is straight. So it's from 0 to 5 seconds. Okay, so I have a straight line. I will say I have a constant, and velocity time graph, the gradient will be acceleration. So I say that I am having a constant acceleration from 0 to 5 seconds. The next section, okay, I hope you are able to differentiate, is from 5 seconds all the way to 10 seconds. Okay, 5 seconds to 10 seconds, I have another type, which is not a straight line. Okay, so you take a look at the gradient. The gradient is actually decreasing, more and more gentle. It decreases. Okay, so if I'm decreasing gradient, means I'm decreasing acceleration. Okay, so from 5 to 10 seconds, how will I describe? I will describe as it's having a decreasing acceleration. Okay, the next segment will be 10 to 15 seconds. Okay, it's a flat line. Gradient, it will be 0, means acceleration will be 0. I'm not accelerating. At this point, I'm moving. As the time progresses, my velocity is always 20. I'm having a constant velocity of 20 meters per second. Okay, the next segment will be from 15 to 20. Okay, 15 to 20, again, is a straight line. So I need to have a word constant. Okay, but now my gradient becomes negative. Okay, means I'm having a negative acceleration. Means I'm decelerating, the velocity drops. So I'm having a constant deceleration here. And then from 20 to 25 is the next segment, 20 to 25. Okay, again, 0 gradient. flat line, 0 acceleration. The car is actually not moving. It's stationary at this moment because the velocity is always 0. Okay, and then the next segment will be 25 to 30 seconds. Again, a straight line. So I'm having a constant gradient, constant acceleration. And the last part is from 30 to 35 is not a straight line. In fact, the gradient is negative, so it's decelerating. Okay, and I'm getting more and more gentle. So it's decreasing deceleration. Okay, it's decreasing deceleration. Okay, next. Okay, you may pause the video for a short time interval to describe the motion. So the first part is from 0 to A. It's not straight line, so it's increasing or decreasing. This part is increasing velocity. A to B, decreasing velocity. B to C, 0 velocity, not moving. C to D is constant velocity. Okay, I hope you are able to explain this. Increasing, decreasing, 0 velocity is at rest, and constant velocity. Okay, the next part, you may again pause the video to think about the answers. Now it's a velocity time graph. It's exactly the same. So, but now when I took a look at the gradient, it will be acceleration. So from 0 to A, I'm having increasing acceleration. A to B, I'm having decreasing acceleration. It's still acceleration because the velocity increases. B to C, I'm having 0 acceleration. I'm moving at constant velocity. And from C to D, I'm having a constant acceleration. Okay, next, a few more examples. Okay, how do you interpret this motion? This is a velocity time graph. So the first step, think of the gradient. The gradient gives you the acceleration. So I'm having a lot of straight lines here. So I will see a lot of constant, the word constant to describe. So the first step, I'm having a constant acceleration from 0 to 10. Okay, segment the graph. You should be able to get this segmentation, 0 to 10, 10 to 15, 15 to 30, 1 segment, 2 segment, 3 segment, 4 segment, 5 segment. Okay, for the first graph. Okay, and then for the second graph, again, I'm going to do segmentation. I should have 1 segment, 2 segment, 3 segment, and lastly, 4 segments. Okay, so if you're able to get it, from 0 to 10 is the first segment. I'm having a constant acceleration. From 10 to 15 minutes is the second segment. I'm going to have a 0 gradient, which means 0 acceleration. Means I'm not moving faster and faster. I'm having a constant velocity of 60 meters per second. Next, the third section will be from 15 to 30 minutes. I am again having a straight line, so I need to have the word constant, but now I'm no longer accelerating, I'm decelerating. So I'm having a constant deceleration. Okay, and then the next part comes the difficult part. Now the graph goes into the negative component of velocity. Negative velocity means that my object is moving, starting to move in the opposite direction. Okay, at this instant, the velocity is 0, means I stop for at a short while, 30 seconds, before I change my direction. Okay, so now I'm moving in the opposite direction. Okay, you can ignore the negative when you read the graph. The negative simply tells you it's moving in the opposite direction. But you can take a look at this velocity. It's actually increasing from 20 to 40. Okay, as the time progresses. Ignore the negative. Negative just tells you it's opposite direction. So it is actually accelerating because it's moving faster and faster from 20 to 40. So it's actually having a constant acceleration, but it's in the opposite direction. That's why it comes with a negative. Okay, and for number 5, section number 5 is from 40 minutes all the way to 60 minutes. Okay, the velocity actually decreases. My velocity from 40, I decrease to 0. I'm slowing down. Okay, so I'm actually decelerating. And it's a constant, it's a flat, is a straight line. So it's constant deceleration, but also in the opposite direction because it falls at the negative part of the graph. Okay. Okay, now take a look at the next example. Okay, so from 0 to T1, zero gradient means zero acceleration, means constant velocity, moving with constant velocity. Second one, my velocity drops and it's a straight line. So I need to have constant. So constant, and since velocity drop, constant deceleration. The third part is when my velocity becomes negative, means I'm moving in the opposite direction from this instant onwards. From T2 onwards, I'm moving in the opposite direction. From T2 to T3, moving in the opposite direction, but my velocity increases from 0 to whatever number. So I'm having a constant acceleration, but in the opposite direction. And number 4 is not a straight line. The gradient is getting steeper and steeper, so I have an increasing gradient. Okay, and in this point, I am decelerating because my velocity is like 40 all the way to 0. So I'm having a increasing, because the gradient is getting steeper and steeper, increasing deceleration, and it's in the opposite direction because it's at the negative part of the velocity time graph. Okay, so summary, remember, whenever we try to explain the motion of a object using graphs, we tend to describe it in terms of the gradient. The gradient of a displacement time graph gives you the velocity, while the gradient of a velocity time graph gives you the acceleration. Okay, and then every time you see a flat line means gradient is 0. Every time you see a straight line means when you are describing motion, it needs to have the word constant or uniform. And when you see it's a curve, you either use the word increasing or decreasing to describe the motion. Okay, we will stop